Thank you guys. So I'll today explain on a new concept called integrated access and backhaul. So how about thinking on a world without cables? So I'm Charita, and this lecture will be focusing on this new concept called integrated access and backhaul. So as we know, for the 5G and beyond networks now routing out in the society, they will be widely be used along this 2020-2030 period. And the wireless communication is a very hot, very active area, which always tries to improve. And this new concept, integrated access and backhaul, is a key feature that will include in the coming 5G networks, not currently in the industry, but it will come out in 2024 or something. So what we know is that 5G and those systems will need lots of base stations. So as you see, there will be a need of having many base stations to have the connectivity that is supposed to have in 5G, unlike in 4G, because in 5G what we deal with is having shorter wavelengths, high frequencies and shorter wavelengths. So these frequencies can't travel lots of distance like we did in 4G. So it won't travel, it won't work if you have one base station at one point and another base station at 2 kilometers or something. So we need to have base stations in like 100 meters, 50 meters, 200 meters, that range. So there will be a densification of base stations that currently needs to happen. And we expect that lots of interconnected vehicles and lots of mission critical systems like fire safety, the fire guard systems automatically working, those systems will have to work with the new 5G and beyond networks that is coming up. So in this case, what we call integrated as access and backhaul is where the access and backhaul links share in the same wireless channel. So what I call access link is the link between if you have a base station, the base station serves for some users like our mobile phones. So the access links are the links that connect those users, the mobile phones and the base station. And the backhaul links are like the like the core network that the spinal cord that carries all of those information between the base stations. So it is like not like only like we communicate with the base station, but the base station also has to carry that load into the core network and to the other base station. So what we considering access and backhaul is that we integrate both of those parts wirelessly. Previously, what happened was access was wireless. That means we connect to the base station wirelessly, but we have fiber optics. In most of the cases, we have fiber optics interconnecting the base station. However, we know that with the introduction of, with the need to densify the network, as I told, we need lots of base stations. So we can't lay fiber everywhere. So it's we needed to come up with a new solution for some cases to have wireless backhaul solution. So the IAB works there. And one key advantage is that 5G works in the millimeter wave, very high frequency range. So we have lots of bandwidth. So unlike in the previous generations, like in 4G and 3G, we can use those excess bandwidth to share that. That means like we have a larger pipeline that you can send more data. So we can use that pipeline, some part to the backhaul and some part to the access. And as even in the Thomas lecture, he's told something called beamforming. And because the new radio comes up with MIMO and multi-beam systems, beamforming those things, the interferences that occur between these wireless transmissions can be reduced. So it increases the opportunity to use that. And there are a few challenges here, but that is like if we, unlike in fiber, the fiber has higher speeds, lesser interferences because it's just wired connection. If you have more hops in IAB, like several base stations that transmit each and every hop, then the latency will drop, and also the interference. We have to mitigate the interference. And if we go to have lots of complex, I mean, many base stations that are connected into IAB network, we need to adapt the control in a complex way. So if you think about an IAB, this is just a simple plug and play. So, but when it comes to fiber, it takes lots of cost, time, and also some places you can't even dig, like in architectural archaeological places where people can't dig in and lay fiber, you should go for an alternative. So we consider something about IAB, and then we something called IAB, and okay. So this is kind of a typical IAB setup. So these, as I explained, these are the access links that connects to the user to the base station, and then you have the backhaul links. So what you consider is IAB node can be even a drone. So you can just put up a drone and then make the same speeds. That is kind of under research and under improvements. They try to make come up with the same or like the adequate speed as of a fiber link. And then if there's an earthquake or a fire or something, and a fire brigade wants to go there and have the same connectivity, we can just drop a drone there. And otherwise it works as a normal network where there are small base stations like working like relays, and there are macro base stations. So the base stations, the macro ones, are only connected with fiber, and the other IAB nodes marked here coexist with the fiber advance. So it is like the macro base station connected to the fiber network will have more bandwidth, and it will share some of its bandwidth to backhaul without having a fiber connection directly to the core network, and without having any wired connection. Some of the excess bandwidth it has, it will use to backhaul or connect these small base stations. And in a hybrid IAB network, what we consider is some of the small base stations we connect it to with the fiber, and then it is typically useful because in some places you already have fiber, and you don't need to lay new fiber there. So some of the small base stations in a city you can already connect with the existing fiber network, and the others you rely on the wireless connectivity. So in such case, you increase the data rate because there's no factoring mu here. There's no percentage that goes in there. It will have the total bandwidth because it's fiber connected. So it's just based on the channel's capacity. It will be proportional to the bandwidth and log 1 plus SINR. And yeah, thank you for the takeoff messages. I would like to say that IAB, we have observed that it gives fiber-like data speeds, not particularly same as that, but it is adequate there, and it's improving. And it's very cost-effective because it's just plug and play. You don't need to spend on digging and so on. And the key factors there, the characterizations, that is, it shares the bandwidth between access and backhaul. And also it can be characterized using state-of-art models to observe how the performance goes on. And it's very simple to deploy, and it is supposed to coexist with fiber, but not to overrule fiber. So if in a network, if there are 100 base stations, about 80 will have fiber links, and the 20 will coexist wirelessly. So that is kind of how it will work. And yes, if there are questions, happy to answer.